Hey guys, welcome to brainAttic. So today we have another very interesting problem from the topic of linear differential equations. This question was very recently asked in JEE Mains. So if you do want to give it a try, you may pause the video now and give it a try. Otherwise, let us continue solving the problem. So we are given a differential equation of the form like this: dy dx minus 3 into x power 5 tan inverse x of q in the numerator, and in the denominator we have 1 plus x power 6 whole to the power 3 by 2 y, which is equal to 2x exponential, and in the numerator we have x cube minus tan inverse x cube, and in the denominator we have root under 1 plus x power 6. Okay, so let us begin solving the problem. We are said that this function, this solution curve passes through the origin, and we are asked to find y at x equal to 1. So we have the differential equation as dy dx minus 3x power 5 tan inverse x of cube 1 plus x power 6 power 3 by 2 y is equal to 2x exponential, and in the numerator we have x cubed minus tan inverse x cube by root under 1 plus x power 6. So straight away we know that this linear differential equation is of the form of dy dx plus py is equal to q. And when we see a differential equation of this form, we know we have to find the integrating factor. Integrating factor. And this integrating factor is equal to exponential power t dx. Okay, so and then the solution is linear differential equation solution is given by y into integrating factor, y into integrating factor is equal to integration over q into integrating factor plus dx. So this is our solution. So we'll solve for the integrating factor, which is e power, or maybe we'll write exponential, and within this we'll write minus 3x power 5 tan inverse x cube whole divided by 1 plus x power 6 cube. 3 by 2 I'm writing in this manner. So dx, and we close the bracket. So to solve this integral, we'll first focus on solving this integral. So we'll take this integral out and we'll write it as 3 power x minus 3x power 5 tan inverse x cube whole divided by 1 plus x power 6 cube dx. So the first step we'll do is that we'll take x cube equal to z. This implies that 3x squared dx is equal to dz. So our integral, let's say this is our integral I becomes of the form minus z tan inverse z by 1 plus z square 3 by 2 dz. Okay, so our integral is of this form. Now again what we are going to do is we are going to take tan inverse z as u. So dz by 1 plus z square is equal to du. How does this help us? This helps us in the following way. So we know that z is equal to tan u minus tan inverse z is u divided by, we have root under 1 plus tan square u, and 1 plus z square is absorbed in this du with dz. So 1 plus tan square u, we can rewrite this as integral u tan u by secant u du, and this ultimately turns out to be minus u sin u du. So by applying partial integral formula, we get that this is nothing but equal to u cos u minus sine u. Now, the trick to this problem actually lies in what I'm going to do next. So, what I'm going to do is that I'm going to make this cos u as secant u minus sine u, and then we're going to see. So, this becomes tan u by secant u. So, we know that u can be written as tan inverse of z. So we write this as tan inverse of z, and tan of tan inverse of z is nothing but z, and secant u I can write it as 1 plus tan square u. Okay, so this tan square u is only thing left to replace with z. So we have tan inverse z minus z by 1 plus z square. Tan inverse of z is u and tan square u, so z square. Next, we can replace with x cube. So we have tan inverse x cube minus x cube by root under 1 plus x power 6. So we have solved the integral, and the integral factor looks something like this. Exponential tan inverse of x cube minus x cube by root under 1 plus x power 6. So this is the major trick in this problem. Now, so we applied this to the solution. So we have y into exponential tan inverse of x cube minus x cube by root under 1 plus 6 x power 6 is equal to 2x integral exponential. So if you see, right, the term q is basically x cube minus tan inverse of x cube by root under 1 plus 6 x power 6, and we got the integrating factor as tan inverse of x cube minus x cube by root under 1 plus x power 6 dx. Okay, so this they cancel each other out, and what we are left is exponential tan inverse of x cube minus x cube by root under 1 plus x power 6 is equal to integral 2x dx, and this is nothing but x square plus c. Okay, now we know that this term, this equation y into exponential tan inverse x cube minus x cube by root under 1 plus x power 6 is equal to x square plus c. This passes through origin. So we'll put x is equal to y is equal to 0, and what we have is equal that c integration constant is equal to 0. So our final equation turns out to be y into exponential tan inverse of x cube minus x cube by root under 1 plus x power 6 is equal to x square. Now we are asked to find y1. So we'll apply x is equal to 1. So to find that, we have exponential. So if I'm supposed to find y1, right, y1 is equal to 1 by exponential tan inverse of 1 minus 1 by root under 1 plus 1, and this turns out to be exponential 1 minus pi by 4 by root 2, and this again I can rewrite this as 4 minus pi by 4 root 2. So if we are supposed to check the options given to us, right? So we see that option C is the right choice. So if you do like the video, hit the like button, subscribe to our channel for more content like this. Thank you so much for watching.